Hello, everyone. Welcome, and thank you so much for tuning in. Just as a quick introduction, my name is Jaime. I am the lead engineering instructor of the part-time remote immersive program, and I'm super happy to have you here today, no matter where you are watching from. So, no doubt you are here to get a little bit more familiar with the technical interview process for Codesmith. Today, we're going to be talking about the best ways to prepare for this technical interview. Now, my general kind of best advice that I have for you at the moment is to definitely attend our JavaScript The Hard Parts workshops. This is really, in my opinion, the best way to improve your confidence and practice your technical communication in real time. I think this is a much better alternative to simply reviewing the many recordings that we have on YouTube or via our CSX learning platform. But if you're really able to, I would seriously recommend it. It is a great way to just get that practice in, get those reps in, and just feel more confident going into the actual interview process. Now, I just want to preface this by saying if you came here hoping to learn something technical tonight, like Clojure or OOP or something like that, you are going to be a little bit disappointed because that is actually not the focus of this recording. This is really going to be about equipping you with the necessary tools to perform well during our technical interviews. I'll be talking about what specifically we're really looking for in our candidates and how to best think about and practice these things. I want to help you develop an overall strategy for any problem that is thrown at you during one of these interviews. This information will also be very applicable to your eventual real job interviews for actual engineering roles. So, before we dive into that, let's kind of go over an overview of Codesmith. If this is your first time here, we'll spend a little bit of time going over Codesmith as a whole, what Codesmith is, and a little bit more detail about our programs before we actually dive into the workshop recording material. So, before we get into the weeds here, what exactly is Codesmith? Well, our mission at Codesmith is to create irreplaceable engineers and technologists. Codesmith is based around an immersive engineering program that aims to develop grads who are autonomous and flexible engineers, ones who are able to handle any problem or technology that is thrown at them. We want to really help folks enjoy the satisfaction of a new level of autonomy in their personal and professional life. We really pride ourselves on working to make sure that tech overall has more people taking a lead who mirror society as a whole. People who understand the problems that need to be solved and have the problem-solving capabilities and capacities necessary to enact real change in the world around us. We are very proud of the fact that our residents and grads come from truly all walks of life. Our immersive program has two different campuses, one that is full-time and one that is part-time. You can see an overview of both programs and their schedules on this slide right here. Our full-time remote immersive program, known as Featree, is 14 weeks long or about 3 months. Our part-time remote immersive program, or Petree, of which I am the lead engineering instructor, is 39 weeks long or about 9 months. So, in case you're wondering which program is best for you, I really recommend that you take program schedules into account and think about what your specific timeline looks like. The full-time program is great for folks who are ready to spend 3 really intensive months and jumpstart a new career quickly. The part-time program might be better if you need a little bit more flexibility. It's popular with folks who want to continue to work, while engaging with the immersive program, or perhaps their parents, or perhaps their caregivers, with important other responsibilities to tend to. When you're trying to figure out which program is best for you or right for you, just know that both programs are open to all and have the same exact curriculum and admissions process as well. So the only difference here is the pacing and the length between these two particular programs. So definitely choose the program that works best for your timeline, your schedule, and your overall lifestyle. In either of the immersive programs, the academic team at Codesmith, of which of course yours truly is a part, will lead your core lectures, will help review material, will help drive your learning and overall growth throughout the program. The team here is really committed to our residents' success, and we commit each time we commit time to each student and follow their journey to help them be as successful as possible in this entire process. I'd really recommend, as I said before, attending one of our public workshops if you are interested in getting to meet any members of our team, as we lead many of these events. So you can check out our website for more information on this, and anything will be helpful there. Cool. So here's a general overview of the admissions process as a whole. The first step is to submit an online application on our website. And this is where you're going to share some information about your experience and your interest in coding. Then you're going to complete an initial interview, which basically consists of a casual chat with a member of our admissions team, just to get to know you a little bit better and what exactly your goals are, what you're hoping to achieve by engaging with our program. Next, you're going to complete a technical interview where you're going to work through JavaScript challenges with a member of our team, and you're going to be assessed on criteria including technical communication, problem-solving capabilities, and overall JavaScript knowledge. We're going to be chatting about this in depth today. Most people don't pass their technical interview on their first try, so do not worry. If this is you, you will have 3 tries to pass, so don't worry about that. Finally, you are going to receive your decision. If you are accepted, you can basically move forward with finalizing your spot in the cohort of your choosing. You can find information on start dates and application deadlines all on our website at codesmith.io. We offer a wide array of free learning resources online, depending on wherever you are in your coding journey and preparation process as a whole. We provide support for those at any entry point. If you're just getting started out, I would recommend downloading our syllabus and signing up for our newsletter on our website. Also, you can check out CSX, our free online learning platform, and our CSX Slack community. This is a great way to meet other folks who are looking to engage with our programs, or perhaps alumni who have already been through our programs. After this, I would recommend joining one of our free events. We have tons for different levels of coding knowledge, from intro to coding and beginner study groups, all the way to our famed JavaScript The Hard Parts workshops. It is great to have you tuning in right now. At any step in the process, please feel free to schedule a call with us. You can schedule a call with a grad. Our team will basically pair you with someone who has a similar background to you, kind of based on your story, or our admissions team on our website. We are totally here to help you out, so please reach out to us if you have any questions or need any assistance with that. If you need a little bit more structure overall, we would recommend doing one of our prep programs right here. These include JavaScript for Beginners and CS Prep. So personally, as someone that came into this line of work from a fairly non-technical background, I personally did them both and I really loved them. JavaScript for Beginners is designed as your very first step into web development, and CS Prep essentially builds on that foundation, giving you all the tools necessary to ace your technical interview. We're currently being generous with our scholarship awards. We are offering a lot of full scholarships at the moment. So if you are interested in applying, let us know and we will make sure to get you the application so that you may apply for discounted tuition in whatever regard. Here is our wonderful community and admissions team. The best way to get in touch with these great folks is in the CSX Slack, but do let us know if you'd like to be connected directly. Do remember that you're also able to schedule a call with a grad or with our admissions advising team on our website, so do look into that if you are interested in that at all. Let us actually get into the workshop content now. So this is going to be a lot of fun. So just to begin, this is a breakdown of what we are really looking for in our applicants. Now, the number one thing that people think they're being graded on in these technical interviews is number 5, JavaScript and programming experience. I can't say enough that this is simply not the case. This is truly a fallacy because there is so much more to being a valuable, impactful, and effective engineer. So if you are kind of thinking this way, I want you to get this out of your head at the moment, that is the number one thing that interviewers are looking for, both at Codesmith and beyond in your eventual software engineering job interviews. It's not just about how technically strong you are in whatever language you are proficient in. Of course, with our program, it's going to be JavaScript. In fact, we aren't really going to work on this at all tonight. We're going to be focusing much more on the above 4 areas that you see on this slide. And the reason that we do this particular workshop is because most people fail their first technical interview at Codesmith. Of course, many do the same in their actual real-life job interviews as well. Now, the number one reason for this is not that they aren't technically capable, but it is because most people, understandably, are not used to programming and technically communicating through their code at the same time. If you're watching this, I highly doubt that most people who are tuning in are communicating their CSX or algorithmic practice out loud. Now, if this isn't you and you are actually doing this is fantastic. And I would really encourage you to keep doing this to practice more. It is rather unnatural at first, but it gets easier over time. I can certainly assure you of that. Now, we're going to focus primarily on improving technical communication, number 2 on this slide, more than anything, but we'll, of course, cover everything in general as well. Now, to improve our ability to interview as a whole, we're going to build a framework and an overall approach with all this information here. Now, by focusing on these 5 key capacities and best practices, you'll be able to approach every problem in a way that's going to improve your communication and just overall performance in technical interviews across the board, whether it's Codesmith or certainly beyond. Let's talk about these 5 criteria more in depth to just contextualize why they are all important in their own rights. Now, number 1 is analytical problem solving. As a software engineer, you are going to be solving new challenges and facing new problems each and every day. Now, all engineering is truly just problem solving and optimizing after that. It's not about what you've memorized or what you already know. This is about how well you're able to break apart a complex or perhaps gargantuan problem into small, more manageable kind of bite-sized pieces and solve those challenges methodically. That is really what we are looking for when we're talking about analytical problem solving. Number 2 is technical communication. Now, you should be striving to have such precise technical communication that someone else in a completely different language or framework can implement your approach to solving a problem without ever actually seeing your code. Perhaps they write in another language altogether. Being able to communicate your thought process through clear technical language is going to show both our interviewers and hiring teams beyond that you are able to enter the workforce with the ability to communicate on a high level with engineering teams and other fellow engineers who perhaps work on other teams. The third thing is going to be engineering approach. Now, every good technical interview should really push one to hit a hard or difficult block. Hitting blocks is not a bad thing at all. In fact, it is one of the most normal parts of being an engineer. So you need to be able to develop your abilities to debug, to reference documentation, and things like this. Interviewers essentially want to see how you handle not knowing or being in an unfamiliar situation where you might not exactly know what is going on. Now, if you took a Codesmith technical interview, for example, and if you didn't hit a single block once in that hour, you're actually not going to pass, and we're going to ask you to come back. And this is specifically because we want to see how you behave when you struggle, when you hit a block, because this tells us so much more about what you are like as an engineer and a problem solver than if you are just breezing through everything without ever struggling, really. So personally speaking, in my day-to-day, I'm looking at documentation, to be honest, a lot more than I'm actually writing code. This is a very normal part of being an engineer. Now, engineering approach is all about how we approach new and unfamiliar problems because this is a very real part of the actual day-to-day. So how do you handle bugs? How do you respond when your code isn't working as expected? How do you parse through error messages? How do you handle not knowing exactly what is going on? What do you decide to do in light of that? And so to move forward, thoughtful communication is really quite simple. This is genuinely code for, and I'm being serious here, for just don't be a jerk. Are you actually enjoyable to work with? Are you kind? Are you someone who I would want to pair program with or be in a project group with? Are you patient when you understand something perhaps quicker, easier, or better than someone who doesn't? If this were a real job, so to speak, are you someone who I would want to sit across or work with hours a day? Maybe for the rest of my life, perhaps. So contrary to popular belief, being a software engineer is actually one of the most collaborative lines of work that you could be in. Unless you are doing, let's say, like solo freelance development, you will constantly be working as part of some team of some size. And that team is going to depend on you being chill and enjoyable to work with. Interviewers are looking for engineers who can be trusted to collaborate well, because that is so much of what this work is, quite frankly. And finally, we get to the last criteria here, which is JavaScript and programming experience. And I want to say, perhaps not contrary to what I said earlier, but just to emphasize this, that this is important. I don't mean to say that this isn't important. I am simply saying that this isn't the kind of be all end all most important thing. You do need to have a solid level of foundational understanding of JavaScript and just computer programming in general in order to be successful as an engineer. So the concepts that you're going to want to have a strong foundation on in order to do well in our technical interview in particular are going to be callbacks and higher order functions, closure, recursion, and object-oriented programming. Object-oriented programming. So to recap, the entire reason that we are doing a workshop like this is not because we want to actually teach you something technical outright. It is not, the purpose of this is not to get you more practice in JavaScript, but instead focus on developing you in these other equally important areas that all comprise what it means to be an effective and great software engineer. So let's talk about best practices for technical communication and how to approach any technical interview question. So if you are into taking notes, perhaps this is a great point to really start doing that. So here's a framework for what we consider good problem solving and technical communication overall. So the first thing that you want to do in this kind of scenario is you want to communicate your overall strategy. When you are beginning to solve a problem, the first thing that you should be doing is communicating your overall high-level bird's eye view strategy for solving it. Now, this is a verbal explanation, and this should be, again, high-level, relatively broad. And it does not have to be extremely technical or specific. It simply has to give your interviewer a general sense of where you are going with your solution. You can kind of think of this as providing high-level verbal pseudocode. And what is really important to engage with this effectively is to ensure that you actually understand the problem. This is often the source of a shoddy or suboptimal approach to solving a problem. And this is the time to confirm with your interviewer that you fully understand what is actually being asked of you. This is the time to ask any and all clarifying questions that you need to. Once you've done this, what you can move on to is pseudocoding your approach. If anyone here is unfamiliar with the concept of pseudocode, this is essentially a written solution or approach in just kind of a combination of plain English and good technical communication. Now, an example of technical communication that would just be far too broad for pseudocode would be something like saying, we're going to look at every single thing in these brackets. That is not really descriptive enough, and it's just not technically precise enough to let me know what it is you're trying to do. Now, on the other side of this, what you don't want to do is actually write like commented out code. You wouldn't want to write, with, let's say, a for loop, for space, open parentheses, let I equal 0, semicolon, and so on and so forth. You want to strike this kind of really beautiful middle point where you are being precise enough, but not to the point where you're simply regurgitating actual code. You would want to say or write in pseudocode something like, we're going to iterate over the array, checking if each element is blah, 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 for whatever it is that you're actually checking for, if you're doing some kind of conditional check, right, in iterating over an array of elements. So this is kind of what we are looking for with good pseudocode. Now, it doesn't have to be super precise, but your pseudocode should basically be slightly more technical and specific than your kind of verbal overall strategy from the previous step. You want to keep this relatively straightforward. Pseudocode is basically meant to keep you on track and to break down your entire solution into more manageable pieces. It's like a set of instructions that you can reliably follow to get to the kind of solution that you are intending to. There's nothing worse than getting lost and overwhelmed in your own code. And this typically happens when you don't write very good pseudocode or write precise pseudocode. It's also going to really help your interviewer understand your thought process, even if, and especially when the actual code that you write perhaps doesn't end up running as expected. You might implement your idea in a slightly incorrect way. But if we get a sense of what that general idea is, and for us to know that they had, that you or whoever else had the right idea, this can really be helpful. So I just want to emphasize that. You should really focus your pseudocode on the main aspects of your solution. So for example, where loops should be, or key pieces of conditional logic, what should be returned at the end of a function definition, and so on and so forth. And I just want to say as a side note that commenting code and writing pseudocode is actually extremely common practice in the industry, and you are going to see this in production level code bases all the time. And this is done to provide clarity when perhaps an approach to some problem isn't kind of readily clear, where context would actually help us, perhaps an engineer reviewing or onboarding onto a new code base to kind of get a better sense of what is actually going on. It is meant to be helpful and guiding. Now, after you write some pseudocode, what you're going to want to do is actually communicate through and write your code line by line. So this is, the point when you've written your pseudocode and you've ensured that you feel good about each main step. And this is the time to start actually for you to start actually writing code to follow your thought process overall. This step should consist of concise explanations of every single line that you write and what the purpose of any given line of code actually is. You can choose to explain first and then code, or vice versa. It doesn't really matter. What's truly important about this step is that you are able to explain why you are choosing a particular tool or approach. You can expand on ways that you are perhaps abiding by best practices, how you're using built-in JavaScript methods like map or reduce or filter, let's say, writing code that is more efficient or performant, perhaps. You might say, right, like, I'm using const here instead of let here to declare this particular variable because we know that we're never going to need to reassign its value. This is a good way to explain reasoning for why you are deciding to write code in a certain way. I'm choosing to use a regular for loop instead of using for each because I know that I'll need to break out of this loop when a particular condition is met. That is also really helpful because if you didn't know this already, using for each, when you use for each, the kind of native built-in JavaScript method, this doesn't allow for breaking out of an iteration, essentially. So moving forward, once you've actually written your code, let's say you hit a block. Now, this is a really important time to communicate out loud when you don't know something. You hit a block, no worries at all. Any good technical interview, as I kind of mentioned before, is purposefully designed to push you to some point where you don't know exactly, or you might not know exactly what is going on. This is not a question of whether you're going to hit a block or not. It is a question of how you are going to handle this block whenever you do hit it, and you will hit it. Our interview will be designed such that you will hit a block at some point. Now, given this fact, how can we reliably handle blocks? We're going to use what is called the Stack Overflow approach, which we're going to talk about more specifically on the next slide, so stay tuned. Whatever you do, when you are at this point where you hit a block and you don't know exactly what is going on, it is really important that you don't panic. Just stay calm, speak clearly and concisely, and try your best to just continually talk about what is going on in here, what your actual thought process is at this point. You should explain your thought process and your just overall reflections as to why this might be happening. We'll talk about this more on the next slide once again, so do stay tuned for that. Now, finally, this last step, number 5, is optional. This is when you want to summarize your kind of approach and explanation as a whole. So once your code is fully written and it's working, perhaps you've written some great test cases to kind of prove that your solution does work. You can basically opt to recap and give a final summation. Again, this step is basically optional, but it is advisable, especially if you had perhaps a difficult time solving the problem. Let's say your approach might have been rather choppy or disjointed, and maybe you feel like you got super lucky at the end or your solution actually happened to work, even though you may not in that moment understand exactly why. This is basically your chance to give a smooth, overall explanation of what you coded line by line. And perhaps this summation may help you understand why something actually works if that was perhaps unclear at the outset. Now, this should in principle be much less hectic since you will have already had the logic taken care of by way of your actual code. All right, y'all, let's move on here. Let's talk about the Stack Overflow approach that I referred to in step 4. Now, for anyone who doesn't know what Stack Overflow is, or perhaps isn't familiar with this, it is basically an online platform, kind of like a forum, where developers ask and answer questions about programming. It's used especially for debugging purposes and error handling effectively. From a technical standpoint, if we're talking about Stack Overflow, aside from kind of this online platform, it's when a program's call stack exceeds its limit. And this can and most often happens with accidental infinite recursion. If you're unfamiliar with this concept, I'd encourage you to review some recursion to get a stronger foundation on that. But to take it back to kind of the reference to the online platform, this approach, these kind of questions that you're seeing on this slide, this is what is referred to as the Stack Overflow approach. Now, this approach is what you should be leveraging whenever you hit a block and don't quite understand what is going on. So what you should be asking yourself in these scenarios is, number one, what is the problem? Number two, what did I expect to happen? Number three, what have I tried? And number four, why do I suspect this isn't working? Now, we call this the Stack Overflow approach because these are the specific guidelines on Stack Overflow for how you are supposed to ask a question on the platform. Now, you may be wondering, why? Why are these the 4 questions to ask? Now, the reason that this set of questions exists and is kind of pushed forth is that it is proven to be really reliable in helping debug issues. And this is because very often, by asking yourself these questions in particular, you actually inadvertently push yourself towards the right answer. I would really encourage you to practice this in your own time as you're just kind of practicing your technical communication or practicing working through CSX problems or CS-bin problems or lead code problems or code wars, whatever platform it is that you use to practice this kind of thing. I encourage you to try out the Stack Overflow approach when you hit a block if you haven't already. I find it to be really helpful in terms of recentering, and there have been many times that I can think of where this has actually helped me come up with a solution on the spot when I perhaps wasn't sure about what was going on to begin with. Anyway, y'all, we're at the fun point of this workshop recording because we are going to do a live CS-bin demo of Memoize, a very, very classic problem that you will kind of that may be familiar to you already, but it is similar to what you are going to, this is kind of the level of difficulty of question that you will encounter in our technical interview in particular. So let me just move my notes over here. We're going to do a fun demo now, and we're going to go into CS-bin to actually do this demo. Don't worry about missing the description here for the actual problem. This is copy pasted in the actual code editor as well, and we'll go over this in depth. So if you're unfamiliar with CS-bin, this is basically a code sandbox that we've developed. And if you're unfamiliar with how it works, I'd really encourage you to practice so that you can get used to the CS-bin environment. We have a bunch of problems on here that you're able to solve, but we're going to be using the CS-bin environment for this actual demo here. So let's talk about this here. So what is the problem that we are trying to solve? Let's actually read through the problem. I'm going to act as if I am in a technical interview scenario and how I would actually choose to approach this problem here. All right, my friends. And thank you again for tuning in, for anyone who is watching this at any point. Okay, so let's recap what's being asked of us and kind of break everything down here. So what are we being asked to do? Define a function Memoize that takes one argument, a function, and returns a function. When invoked, Memoize should create a cache object that tracks invocations of the returned function, wherein each input to the return function is associated with its corresponding output. Any subsequent invocation of the return function with the same argument should return the output directly from the cache object instead of through invoking the original function again. Okay, so how am I going to begin to solve this problem? Well, what I think I'm going to do is I'm definitely going to declare a function. What I need to do is declare a cache object as well that's going to hold key value pairs. Now, what are these key value pairs going to be? Well, I think what my approach is going to be is that I'm going to have the keys of this object be any recorded inputs into this return function. And the values of these keys are going to be the corresponding outputs. And when I say outputs, these outputs are going to be the result of invoking the function that is passed into Memoize, invoking that function on the input and storing that result. So once again, I'm thinking that the keys are going to be the inputs into the return function, and the values are going to be the corresponding outputs that are the results of invoking the passed in function, the one that is passed into the outer function Memoize, and basically to produce a value. And that's going to be the value of the keys in my object. And I should have said this before, but kind of the approach that I'm going to take with this is going to be one that leverages this concept of closure, because I can kind of recognize that this is a closure problem. Now, how do I know this? I know this because our problem is saying that our function Memoize is going to take a function as an argument, and it's going to return a function. So this kind of clues me in to the fact that this is basically a closure problem. So anyway, I've thought about this cache object where the keys are going to be inputs and the values are going to be outputs. And so with my returned function, what I'm going to want to do is I'm basically going to want to check. I'm going to want to check to see, does the argument that is passed in to the return function, does that already exist as a key in my cache? Because if so, then I know that this return function has already been invoked with this argument before, because I would have stored it in the cache object. So I'll know without a shadow of a doubt that I've actually invoked the return function before with this argument. And so if that's the case, what I want to do is I want to just return the value that is associated with that key, right? The keys are the stored inputs of the arguments that have already been invoked with our return function. Otherwise, what I'm going to want to do is I'm going to want to invoke the basically the callback that is passed into the outer function. I'm going to want to invoke that on the argument that is passed into the return function. And then I'm going to want to store that in the cache object. And then I can basically safely return that value from there. Okay, so I think I've outlined my general high-level approach. Let me just take a second to write some pseudocode so that I have a solid kind of blueprint and kind of a set of instructions that I can reliably follow to arrive at this solution that I'm kind of thinking of. So let's kind of break this down here. I'm also the kind of person where I like to basically write the pseudocode kind of above the actual code. Some people prefer to write their code under every line of pseudocode. Either approach is totally valid. It's just a matter of preference. So I'm just going to do my preference. But if you are comfortable with the other kind, please do it that way. Anyway, so let me write my pseudocode for this problem. So the first thing that I want to do is I want to declare a function. What is this called again? Called Memoize, right? Okay. So once I've declared this function, I'm actually just going to go one line here. What I'm going to want to do, right, is I'm going to want to declare a cache object to hold input and output pairs. Okay. Then what I'm going to want to do, right, this is a closure problem, so I want to basically return a function. No, I'm going to take this the long way, actually. I'm going to really do this methodically, where I'm actually going to declare an inner function. I'm going to declare a function, and I'm just going to call this inner for simplicity. So what do I want to do in this kind of inner function definition? What I want to do is I want to check to see if the input exists as a key in the cache object. And after that, what am I going to want to do? Right, this is a conditional check. So if this is true, I'm going to simply want to return the value at the key of the input. Cool, because if it exists as a key, right, this means that I've actually called the inner function with this argument before. Okay, yeah, that makes sense. Return the value at the key of the input. Cool. Otherwise, or else, what I'm going to want to do is I'm going to want to, sorry, this is going to be an if statement, so I'm actually going to want to do this here. So otherwise, what I'm going to want to do is I'm going to want to store the key value pair in the cache object, right? And finally, I'm going to return the value, basically, of invoking kind of that callback function passed into Memoize. Yeah, I'm going to want to return that value. Value, again, referring to the value that is returned from invoking the callback function that is passed into Memoize on the argument passed into the inner function. Okay. And then what I'm going to want to do is, after that, I just want to, because this is closure, and we want to return a function definition, I'm going to return the function definition for inner. Okay. We kind of think about this. Let me kind of read through my pseudocode here to see if this makes sense. Declare a function called Memoize. Okay, so my outer function. I'll write here just for clarity here. Takes in a function or a callback as an argument. Okay. Then I'm going to declare a cache object to hold input and output pairs. So input dash output just meaning like a key value pair where the key is an input and the value is an output. Okay. So within my outer function, I'm going to declare another function within its function definition called inner. And in the definition of this function, inner, I'm going to check to see if the input exists as a key in the cache object. If so, I'm going to basically return the value at the key of the input. Yeah, that makes sense. Otherwise, I want to store the key value pair in the cache object because this argument hasn't been seen before. Basically, this is to say that we have not invoked inner, the returned function, on the argument that is passed into it. And then after we safely store that key value pair in the cache object, which will persist, right, because of closure, we're going to want to return that associated value. And then that is everything in the body of the inner function. And so we're back in the outer function here. And what I need to do, because this is closure, is basically return the function definition for inner. Not an invocation of inner, but the actual function definition for it. Okay, I think I'm in a good point now. So let me actually write this out. And again, I'm the kind of person where I like to write my code under my pseudocode so that I can just watch it and kind of look to it as a blueprint. Again, this is just all personal preference, totally up to you as to how you want to do this. Okay, I'm also going to be using ES6 syntax. If you're less comfortable with that, no problem at all. You can use ES5 function syntax. I just like to write a little bit more modern of a way, so I'm going to use ES6 arrow functions just because that's what I'm comfortable with. Okay, so I'm going to declare a function or a constant labeled Memoize, and this function is going to take a function, right, as an argument or a callback. I could also call it callback. I'm just going to call it func to mean function. Okay, so I know that my function Memoize takes in a function as an argument. Okay, great. So what I want to do, I'm going to follow my pseudocode. I'm going to declare a cache object to hold the input and output pairs. So I'm going to declare a constant labeled cache and set its value to an empty object. Okay, now that I've done that, I can basically safely declare my inner function. Okay, let me just declare and kind of write the blueprint for that out so that I can start to follow my pseudocode. I'm going to declare a function labeled inner. And inner is basically going to take in an argument of some kind, right? For the purposes of the kind of example that I'm thinking of or how I want to test this out, the argument is going to be a number, and I'll kind of make that clear as I write out my test cases later on. But anyway, I have my inner function definition here, and I just have to basically fill it out. Okay, so what I want to do is I want to check to see if the input exists as a key in the cache object. So how can I do this? What I can do is I can check to see if the value of the at the associated key of whatever the argument is, if that value exists in my cache basically, or if the argument exists as a key in the cache. I can do this by checking to see if the value at the key of the argument is not undefined effectively, then I'm going to want to return that value, right? And so I'm going to use bracket notation to do this. I'm simply going to return that value, and how I can do that is simply by writing cache at the key of the argument, right? Because this is basically going to give us the value that is associated with that argument or that key in our cache object. Okay, so I think that makes sense to me. And I know that otherwise, so I'll just write an else statement here. Otherwise, what I'm going to want to do is I am basically going to want to store this key value pair in the cache object. So I can use bracket notation to do this, where I want to basically say, hey, in my cache object at the key of arg, I want you to create this. I'm going to assign that key the value of what again? Let me think about this. Store the key value pair in the cache object. What did I mean by that? Right, I want to invoke the function. I want to invoke the callback that I passed into Memoize on the actual argument. I should have written that probably a little bit more precisely in my pseudocode, but I'm able to kind of reflect on what I meant simply by following the pseudocode. So I'm going to create a key in my cache of whatever the argument is, and I'm going to set its value to be the evaluated result of invoking the function on that argument. Finally, when I do that, then I can safely return, right? I can return the value at the key of whatever the argument is in our cache, because I've actually stored that on the line below. So this is a new invocation, right, of our function, because we've not hit this condition, which is to say that it is undefined, or we haven't encountered this argument before. So again, I'm going to want to store that in my cache, and then I'm going to want to return the value, which will basically be this the value of the evaluated result, rather, invoking the function on the argument, and then I'm going to want to safely return that value right there. Cool. This makes sense so far. And so I basically finished writing my inner function. That's all the logic for my inner function. And again, because this is closure, what I want to do is I want to return, right, the function definition for inner. I don't want to return the evaluated result, because that's not how closure works. I want to instead return the actual function definition. Again, this is a function, right? Even though it's being declared with const, because this is ES6 arrow syntax. Again, I could rewrite this with ES5 kind of function syntax, but this is just what I'm comfortable with. So hopefully this makes sense. Okay, I think I'm happy with my function definition as it stands, and I want to test it out. Now, how can I test this out? Well, the way that I can test kind of a closure scenario is what I want to do is, firstly, I want to declare a simple callback. And I think the callback that I'm going to declare is something really straightforward, like multiply by 2. So I'm going to declare a function called multiply by 2. And what multiply by 2 is going to take in as an argument is basically a number. Let's just call this n. And what I want to do is I want to return n, the passed in number, right, times 2. So when I invoke multiply by 2, let's say on 4, right, that's going to give me 8, because n is going to be 4 in that scenario after matching up our parameters and our arguments. And we're going to return 4 times 2, which, as we know, is 8. So again, this is a really simple callback function, and all it does is it takes in a number and it returns that number multiplied by 2. Okay, so how can I test out my Memoize function? Well, what I can do is I can declare a function called Memoized multiply by 2. And what Memoize multiply by 2 is going to take in, what this is going to be, this is not a function. This is actually just a constant called Memoize multiply by 2. And what I'm going to assign this is the evaluated result of invoking Memoize, the outer function that we've written here, effectively, passing in our callback function, or multiply by 2. So now we're going to be able to keep track of a cache object across invocations, because again, that's just how Clojure works. And we'll be able to, actually Memoize some inputs here. Okay, I feel good about this. And so I can basically invoke this inner function, right, by actually invoking this. Because what does Memoize return? It returns the function definition of inner. So when I am invoking Memoize multiply by 2, what I'm actually invoking is inner, passing in whatever argument that I pass into Memoized multiply by 2. Okay, so let me start to test this out. What I want to do is I want to console log the evaluated result of Memoized multiply by 2 passing in 4. So what should I expect to see as a result of this console log? I should expect to see 8, because 4 times 2, right? Again, inner is really just going to be multiply by 2 effectively, just a memoized version of it. But when I invoke inner passing in n, right, passing in a number right here, I should get 8. Okay, let's run this code first, and let me just see what happens. Okay, I'm now executing code, and I can see in the console that I get 8. So this is these are the beginnings of an indication that perhaps things are working as I intend. Okay, this makes sense. Now, how do I prove that we are actually returning from the cache? Well, first of all, what needs to happen is if I console log Memoize multiply by 2 again, passing in 4, this should also log 8. But I need to find a way to prove that this is actually coming from the cache object and not a result of invoking multiply by 2 kind of freshly on the number 4, right? Let's just test this out first. Let me just see if this is expected, and we can go from there. Okay, as expected, we also get 8. And this makes sense because these two lines of code are basically identical. But I don't want this to be right for the wrong reason. So again, I'm trying to think of how I can prove that 8 in this kind of second console log is not coming from invoking multiply by 2 on 4, but instead actually coming from the cache object itself. What I can actually do here is first of all, I can actually console log the cache object. I can do this from the inner function. And then what I can do here as well is if I hit this condition right, which is to say that we have invoked the inner function with this argument already before, what I can console log here is, hey, I am returning, hey, I am returning from the cache. Okay, I have a couple of console logs that I think will be really helpful to me here. So let's kind of see what the result of these console logs are. Kind of a tip I like to share as well with people is it is really useful to basically console log a string describing whatever it is that you're trying to console log before you actually console log that thing. That way in the console, you don't kind of lose track of what you're trying to console log. I find it to be very helpful. So let's run the code and kind of understand what's happening here. Okay, let me kind of dissect what's going on here. So on the first side, I'm getting a cache object that's showing basically an empty object. Now this makes sense because in this kind of first console log, I've not invoked Memoize multiply by 2 with any argument before. This is the first time that I'm invoking it with any number, let alone the number 4. So the result of that kind of first console log that's coming from this console log, right, is going to be an empty cache object because we've never invoked Memoize multiply by 2 before. And so the second console log I get is basically 8. And I'm not getting this console log because I'm not hitting this condition here. I'm instead hitting the else because we've not invoked inner with the argument of 4 before. So all I do is in my cache store a key of basically 4 and a value of 8, right? The evaluated result of invoking multiply by 2, passing in 4. And then I return that value. And that's what I'm seeing here. Okay, the second time that I invoke Memoize multiply by 2, passing in 4, I now see an updated cache object, right? Because its state persists over invocations, because this is how Clojure works. And in the cache object, I am seeing that we already have a single key value pair, a key of the number 4 and a value of the number 8. Okay, as a result of this console log here, I'm actually seeing 3 lines instead of 2. Why is that? Because I'm seeing an additional console log. Hey, I am returning from the cache. That's coming from here, right? Because we are hitting this condition. Cache at the argument of cache at the key of arg, which is 4, is not undefined because we have invoked the inner function with this argument before, right? We did it on this line here. So it makes sense that I'd be hitting this console log because I am actually returning the value from the cache this time. This is to say that I'm no longer doing unnecessary work by invoking the callback function on the actual argument. I don't need to do that again because I've already stored the key value pair in the cache object. So hopefully that makes sense. Now, what can I do to test this further? Well, what I want to do now is I want to actually console log the evaluated result of Memoize multiplied by 2, passing in a new number now, a new argument, let's say 2. And so I know that this should log 4, right? Okay, let's test this out. I should only see I should see the cache object as a result of this line, but I should not see a line saying, hey, I'm returning from the cache, because we've not invoked the inner function with 2 before. So let's run this code and see what happens. Okay, makes sense. The cache object still only has one key value pair of 4 and 8, because that is the only argument that we have invoked the inner function with before. We've just invoked it with 4 twice. So we just have one key value pair. And otherwise, I'm receiving 4 in my console. This is because we're seeing the evaluated result of invoking Memoize multiplied by 2, passing in 2. So predictably, right, just like above, if I console log Memoize multiplied by 2, passing in 2 again, I should expect to log 4 again. The key difference, right, is that I should actually see 3 lines as a result of this new console log. I should see an updated cache object where I see another key value pair, and I should see this string, hey, I'm returning from the cache, because we've invoked Memoize multiplied by 2, or the inner function with 2 before. So let me run this code. Okay, in my updated cache object, I have 2 key value pairs. I have a key value pair of 2 and 4, and another key value pair of 4 and 8. And of course, predictably, I do see, hey, I am returning from the cache. And then I see 4 because we know that 2 times 2 is 4. Memoize multiplied by 2, passing in 2 should predictably give us 4. Okay. This to me has indicated that kind of beyond a shadow of a doubt, this is working the right way. I'm kind of proving that my cache is updating across invocations. I'm proving that we are storing kind of pre-computed key value pairs or pre-computed results to a certain input in that cache object. And we saw that with 2 examples here. So I hope that all makes sense. If this is really overwhelming or this doesn't make sense at all, I'd really encourage you to kind of review Clojure in particular. All this problem is dealing with is Clojure at a high level. So hopefully this makes sense to you after reviewing that. Additionally, if this is you. Okay, let me kind of engage with this optional last step where I'm basically going to kind of sum up what is happening. And this is going to perhaps help me make any sort of optimizations that might not have been kind of clear to me from the outset. So let me kind of walk through this code again. So what do? I declare a function labeled Memoize. Memoize takes in func, which is a function or a callback as its argument. And in the function definition of Memoize, first thing I do is I declare a constant labeled cache, and I assign its value an empty object. Okay. Then I declare another arrow function, an inner arrow function. I'm appropriately calling it inner. Inner takes in arg as an argument. We don't know exactly what that argument is. In my example, it was a number, but it could really be anything. It could be a string as well. And then this inner function definition, I'm actually going to remove these console logs because I don't really need them, or I'm going to comment them out for now because I don't really need them as I'm kind of summing up here. But in my inner function, I have a conditional check. I'm checking to see if the cache at the key of the argument passed in is not undefined, which is to say that we have stored this in the cache already. then we're gonna want to return the value associated with that key. Otherwise, I'm going to create a key of whatever that argument is in my cache, and I'm going to assign it the evaluated result of invoking func, the callback function passed into Memoize, on the argument that is passed in to the inner function. And then I'm going to return the value associated with that key of whatever that argument is. Okay, something that I notice actually is that this else keyword is actually unnecessary. Why is that? This is because if we hit this condition, we are returning out of the function. So if we're going to return out of this function if this condition is true. So this is to say that we don't actually need an else, because otherwise we're going to, if we don't hit this if condition, we're not going to do this. So I don't really need this else keyword. Hopefully that makes sense. I can actually take this out, and just to be clean here, I'm going to indent these slightly less. Again, I don't need to write an else, because it's only if I hit this condition that we're actually going to return the value straight from the cache. If not, so automatically otherwise, right? Then we're just going to do this logic over here. So again, if we don't hit this condition here, we are going to create a key value pair in our cache with a key of whatever the argument is and the evaluated result as its value of invoking the function, the callback function on the argument, and then we're going to return the value at that particular key of whatever the argument is. Okay, this is a little bit cleaner. I was able to do an optimization right as a result of summing up my approach. And this is kind of one of the benefits of doing this. Hopefully that is clear. Let me just put back these console logs and kind of run all the code again, just to make sure that nothing's changed. Cool. I can see that nothing has changed. We're all good here. If I remove the console logs, I should just see 8, 8, and 4, and 4. Okay, fantastic. I am pretty happy with this with the solution, this approach, and scene. Hopefully this was a good example of how you should be communicating your thought process and approach in our technical interview. Hopefully this gave you an idea of kind of what will be expected of you, what we're really looking for. So yes, I hope this was a fun and engaging demo and gave you some insights there. Alrighty, let's move forward here. Sorry, just gonna get my notes back up here. Okay, y'all, let's kind of summarize everything that we spoke about in this workshop recording. So I just want to remind you all that you will specifically be working in CS-Bin for the Codesmith technical interview in particular. I would, again, encourage you to get familiar with it if you aren't already. You don't want to be exploring the ins and outs of a new code editor during the actual interview. So you want to kind of get that out of the way so you're just feeling comfortable already. This will help to kind of alleviate any perhaps anxiety that you might feel. And yeah, so with regards to the actual interview, I want to say as well that the way the interview is designed is that the problems will never end. There's no finish. The questions are just going to get progressively more difficult, and it's going to be about how far you can get within an hour's time. Sometimes test cases will be given and sometimes they won't. So I'd really encourage you kind of in that example in the demo for you to practice writing your own test cases. Getting good at this is a really important part of being a solid engineer. So I'd encourage you to practice that if you're feeling a little bit more uncomfortable with that. I wouldn't bank on it in general. So just be prepared to write your own test cases. It's a really core part of this whole process. Something you should also be doing is asking clarifying questions. That is more than welcome. I don't want you to be afraid to ask during the interview. Your interviewer is not going to be a brick wall. They want to see you succeed, and they will help you whenever they feel like it's appropriate or might give us some more insight into your thought process in a productive way. You will get personalized, actionable feedback from the team after every single technical interview that you do take. And something that I really want to emphasize here is that you are absolutely welcome to Google stuff during the technical interview. You should if you need to. This is a very normal part of engineering, and we don't discourage this. I have never had an interview of any kind where that wasn't allowed to some degree. That said, the kind of caveat here is that what you cannot do during a technical interview is definitely kind of directly look up a solution or use like ChatGPT or OpenAI or any sort of AI assistance, because that would kind of defeat the purpose of getting insight into your actual problem solving. So feel free to refer to documentation like MDN or W3 Schools, or perhaps your own notes. We'll ask that you kind of share your screen as well so we see what those notes are. But otherwise, the only thing that kind of just isn't flat out, that the flat out isn't allowed, is something like ChatGPT or AI assistance. But everything else in terms of research and documentation is absolutely fair game, and we honestly encourage it. So anyway, all, to wrap things up, let's kind of go over a general summary and overview of everything that I spoke about today. So to effectively solve and technically communicate through any problem, you want to make sure that you are communicating your overall strategy. You want to pseudocode your approach. You want to communicate through and write your code line by line. And you want to communicate when you don't know something. Lastly, optionally, of course, and especially if perhaps your approach or actual execution of that approach was maybe a little bit choppy or disjointed, you can summarize your explanation. As you hopefully saw during the demo as well, this kind of helped me in that example come up with an optimization to my solution, where I eliminated an unnecessary piece of logic effectively, or an unnecessary keyword more precisely. Okay, when you hit a block, you want to ask yourself these 4 questions. Don't forget the Stack Overflow approach. So you want to figure out what is the problem. You want to ask yourself, what did you expect to happen? You want to ask yourself, what have you already tried? And lastly, why do you suspect that this isn't working? We want to get your insights into this. And this kind of framework of these 4 questions, once again, is meant to help yourself arrive at what the problem might be, to get an insight or an aha moment into what is actually going on. And often you will be surprised. This 4-question framework inadvertently helps you do this. And lastly, really the biggest thing to emphasize here is that your overall knowledge of JavaScript is far from the only measure of whether or not you will be successful as a software engineer. Those other 4 kind of criteria that we're looking for in our applicants, they are just as important as your foundational JavaScript knowledge, and you should seek to certainly improve your performance across the board, across these 5 kind of main criteria. And I guarantee that this will really help you in your real-life technical interviews as well, when you are done with the program, when you are on the job search, and so on. Anyway, y'all, thank you all so much for tuning in. It was a pleasure to have you here today. I hope you got some value out of this. Once again, my name is Jaime, and I am the lead engineering instructor of the part-time remote Immersive, and I really hope to see you soon, whether it's in a workshop or a public talk, or perhaps in the actual Immersive program itself. Would love to meet you, and I look forward to it if so. Anyway, thank you so much. I hope you have a great day or night wherever you are. Cheers.